Hello, my name is Kevin, and I'm a postdoctoral research fellow in Psychiatry and Neuroimaging Laboratory in BWH. And I'm going to talk about GitHub for open science today. I'm going to start off by giving you an example of version history in our daily lives and what Git is and what GitHub is in relation to open science. So version history and the ability to restore, I guess you've used it at least once in your work. For example, in Google Drive, there's a function to go back into the previous version of the file if you made any mistakes, for example removing the important paragraph and you realize that after a few days. So there's a function to go back in time. Same as for Dropbox, if you made a mistake you can also go back in history to a previous version. This saves our lives more than once probably. We can also know what was the change by reverting it back, and who made the change by looking at the name, and when was change made by looking at the information of the time. And we can even also document why the change was made if we have separate documents saying, oh, this version is for this and that version is for that. And we can restore it. Is really useful. So having the ability to look at version history is really convenient. However, if you think about this pathway, which you have a file and you work on it and make an edit, while other people work on the same version of the previous file and make their own changes. And then there is a time when you want to merge two different files and then pick out the lines that you want to keep in the final file. There's no functionality of doing this in Google Docs or Dropbox yet. So having this full ability of merging and branching out is fairly important and has been used in scripting and coding and programming languages for some time. And Git, which is the version control system that controls this branching and merging of different versions of files, has been there for a while for software engineers. And this has been a very useful tool to see how your script or text file is evolving, and also helping you collaborate with other people on the same project, because you can also know who made which changes and why and when. You can visually see, you can select the best version of your project going for the final result. So this Git is a free open source and is a version control system designed to handle everything from small to large files or large projects with speed and efficiency. For example, if you think about the version history in Google document, you can just see the previous version looking at the entire document, but here in Git you can only highlight the difference between the different versions. Because they are text file, you can see, oh, line 5 has been replaced into something else, and then line 7 has been replaced to something else in this branch, something like that. So it is very useful collaborating tool which has been in use for a while. And GitHub takes this version control system a step further by mixing the society through internet. So this platform allows sharing all the version history from a individual to a larger group in different side of the world. For example, if the other larger group made a system, you can, on individual on the other side of the planet, can see, oh, that system has evolved from the initial version into the next version because of what and by who and when, and each line of the differences between different versions. So by opening this version histories to other people, you can freely copy and share different versions of softwares as well as your final version for your programming or your scientific research as well. Since it has all the histories, other users can pull the repository or pull the project, and then revert it back to the previous versions if that applies better to the user. So it has the ability to going back, sharing, and so on. To put it back, so it can share the files with Git version history, files or scripts, and it is a really good platform to collaborate with other users. For example, they can also get the files and then branch out by making their own changes, and they can also merge it back to the master repository, suggesting that, oh, this line that I made is actually working better in this environment and so on. If they say, oh, it is actually working better, then we can merge it into the master, we can question, we can comment, and we can follow other people like our social network. So it's adding this social diversity to this version control system all over the planet through internet. So this platform is helping share and collaboration. In open science, sharing the code used in a publication is very, very helpful for other people who's trying to follow the same research. For example, if one shares a testing data with the exact same code that was used in the publication, we can test if the same testing data results the same output, checking the reproducibility of the research. And also, if one has a similar data set for with the similar hypothesis, one can retest the hypothesis which was published in previous research using the exact same line of codes shared through GitHub. So we can also test replicability. Since it has a version history, users can know why each changes were made, and we can revert it back, of course, if previous versions work better, and build a network. You can ask for help for others by commenting on the code or asking questions in the issue page, or you can also answer to different questions, helping others. So this GitHub, this version control, sharing code society on platform definitely helps towards open science. However, not many people actually use this in science because why? It has a steep learning curve. It can appear quite difficult if you try to dive into every function of GitHub because it's quite a massive system. And also, if you read through different threads, you don't understand the terms that the IT and engineering people use, and they sound like talking differently, and literally no one uses it around me. That's the problem. However, you don't have to learn everything in the beginning, so you can just learn a few functions in the beginning and then use that and start using it and start sharing and downloading and collaborating with others, and then learn later. And think about it, those IT and engineering people have shared their code freely available on the internet. So it is highly likely that they will help you, and they will at least try to help you. And if you start using it and then people see value in it, other people will definitely follow using it up. So this is a few examples that can, I think this may draw attention of a few people. So Human Connectome project is a massive project with massive data set as well as very stringent pre-processing code and programming involved in the project. So if we search Human Connectome or fMRI in the GitHub, there are a bunch of openly available codes or scripts you can download, we can share, you can make edits to. So go to github.com, which looks like this, and then you can sign up with your email ID, then you will get GitHub ID, which will be able to log in, and then you can search for it. So once you log in, you'll be able to search whatever that you want to look for example, Human Connectome at the top here. You'll be able to see all the different repository freely openly available for others to use, so you can copy them. So once you find the repository that may be helpful to your research, you can go to that page and then click on code and download the zip. As simple as that. Then you have the code, you have it ready for you, so you can dive right in using it, try using it, verify it, ask questions. Also, if you are more familiar with using terminals, you can copy the address of the repository page and then go to the terminal and do git clone and just paste the address. Then you will have the file in your system. It's very simple to get someone else's code that they have used in their publication. This is a really good tool, even if just use GUI, click code, download the zip. Step further, you can share your code or create a text file that can be helpful for others. For example, if you go to a GitHub, you look at the right top, then there will be a plus button, and then click on the new repository. And you just give it a name, whatever that you want to name it. I named it GitHub_test, and I give a short description, like this is my open source GitHub test script. Make it public, or you can make it, of course, private first, and then once you decide to share it, you can change it to public. And then click on create repository. Then you will see a page, empty page with your title and description here. You can now just upload whatever that you want to share, preferably in a text format like script or Python code or shell code or Java code, whatever. You can upload it by clicking add file and upload files, or even you can create new files on the web. It provides you a text editor where you can put your information to be shared with others on the web. So you name it like this, and then you just give content and you commit new file. Then it will be uploaded to your GitHub like this, and you will see the content whenever freely open, available for others to see. So since it is based on the version control system, you can whenever you make change to your file, for example, when you click on the edit button and whenever you make your changes, you need to give the title of the change, each change. Why are you changing this? What is the reason for this? What would you name this? You can add all that information to here after editing your file, and then you can commit changes. Once you commit that, you will see the same file in the GitHub repo, but once you click the history, now see you have the second version of your text file. And then it even highlights, once you click each version, it even highlights what was the difference between this version and the previous version. Is focusing on the number that I changed, so I can just focus on what was the change, and then it gives you the title and the notes that I used, like when I was making the changes. I can easily see why those was made a change and what was the change for, and when and by who. So this is all there is to it. So you can just start using with online GUI first. Once you get grip of it, you can start using in your terminal. Of course, using GitHub in the terminal is much faster, but it is enough to understand how GitHub works by just using the online platform. So once you get used to it, you can use commands like clone, which you used before, git clone the address, then you're going to pull the repository, and then once in a while, if the author has made any changes to the code, you can just pull the changes by doing git pull. And same as you've edited a file online, you can comment what was the change for, and then push your changes to upload. You can start with this full commands line or the GUIs on the web, but now you know, for summary, GitHub is a version control system for sharing and collaboration with others, especially for codes or script used in science. And it definitely helps towards the open science for reproducibility and replicability and to build a network. So remember git clone, git pull, git commit, and git push, and start using GitHub. If you have any questions or comments, give me an email or send me a message through GitHub. Thanks.